Page 257, lesson 5.1 is on estimating solutions by inspection. And we're going to be looking at how slopes and y-intercepts are related to the number of solutions of a system of linear equations. If you go over on page 258, example 1 gives us a lot of information about what we're going to be doing in this lesson. So to start with, what is a system of equations? A system of equations basically is if we have two or more linear equations and we have the same variables, that's called a system of equations. With what we're dealing with at this point, we're probably just going to be given two equations, but you could have 3 equations, you could have 5 equations. There's really no limit to how many equations you could have for a system of linear equations. And we're going to go down a little further on the page for a minute. It talks about a solution of a system of linear equations is any ordered pair that makes all equations in the system true. So a couple ways of looking at that. One thing for a solution, we could say graphically, which is what we're mainly going to look at in this section, from a graphical perspective, a solution would be where the graphs intersect each other. So if you have two lines, where do those lines intersect? That's our solution for a system of equations. Another thing which you'll learn more so when you take algebra in high school is we can actually work these problems out by hand rather than graphing them, and from working it out by hand you can also figure out what ordered pair works for all the equations. So we basically have 3 different possibilities when we do these problems. So one possibility, which is actually pretty common, it's more common than you might think based off of what we're going to do in this lesson, but this is actually the most common scenario that we should have when we do these problems, realistically, is where we have lines that intersect at one point. So if they intersect at one point, we have one solution. So if you look at this graph, these lines intersect at the point 1, 5. And what that means is for these equations, 1, 5 works for both of these equations. What do I mean by that? Well, look at this equation. We've got y equals x plus 4. If we put a 1 in place of the x and a 5 in place of the y, that equation should work. So 5 equals 1 plus 4. That works. Same thing with our other equation. If we put a 1 in for x and we put a 5 in for y, 5 equals negative 1 plus 6. That works as well. Okay? That's the only coordinate that works for both equations. Okay? So like for example, that first equation, we could have put in a 0 and 4. 0 for x, and 4 for y. And that works for that equation. But if you try 0 and 4 in the other equation, that does not work. Okay? So the only thing that works is for both equations is putting a 1 in for x and putting a 5 in for y. And you can see that because that's where those graphs intersect each other. That's the solution then to that system of linear equations. Another case we could have is something like this. So if you look at this, you can see from the graph these lines are parallel. So if the lines are parallel, that means we have no solution. No solution because the lines never intersect. There's no x and y pair that works for both of these equations. So no solution on that one. And if you'll notice, something we could watch for is based off these equations, you might notice they have the same slope but different y-intercepts. So the slope is both 1 The slope tells us the steepness and the direction. So if their steepness and direction is the same, but they start at different y-intercepts, they're never going to intersect each other. They are going to be parallel lines, okay? So no solution for those. And then finally, a third case is another possibility. We have these lines intersect at every point. Infinitely many solutions. No matter what value ordered pair we pick, as long as it's on one line, it's also going to be on the other line. And if you'll notice the equations here, those equations look different. These look different than each other, but actually if you think about that first equation, if you multiply by 3 on both sides, that'll give us an equivalent equation, and that's what's happening. Multiply that top equation by 3 and you get the second equation. So you can see how those are basically identical equations to each other. And this one, you can't really tell by the format, but these have the same slope and the same y-intercept. So they are the exact same line. We have infinitely many solutions. If you were to go through and solve this, if you were to solve both of these for y, you would get y equals negative x minus 2. You would get that for both equations. Okay? So if we solve for y and we get the same exact equation, they're the same line, they're always going to be intersecting each other. So infinitely many solutions for that system of equations. So if we look at the try it, how many solutions does this system of equations have, and explain? So we'll look at the equations here. What the book is wanting us to focus on is on the slopes, whether the slopes are the same or different, and then from there also we can look at the y-intercepts. One thing I didn't point out as much at the beginning is that first case where we had one solution, those lines had different slopes. The slopes were different. If their lines are angling different, they're going to intersect only in one point if they're straight lines, okay? So if we look at these lines, trying to find the slopes first of all, remember we have y equals mx plus b. M is our slope. So the first equation, I don't see a number. Remember, we can always put a 1 there. So the slope of this first equation is 1. The slope of the second equation is 2. This was a very poor choice of numbers, by the way, because if you'll notice, we have both 1s in the first equation and we have both 2s in the second equation. So you could have been looking at the wrong number and there'd be no way to tell, did you guess the right number or were you actually looking at the y-intercept instead? But anyway, you guys knew what to do, so it's fine. So slope on the first equation was 1, slope on the second equation was 2. So we're going to go to the second blank here. It says the equations have blank slopes. And so remember, one of the slopes was 1, one of the slopes was 2. That means they have different slopes. Different slopes, that goes back to the first case in your book with the blue lines. You can see on example 1, the blue lines is an example of that. If they have different slopes, they're going to intersect at one point. And I would have put this sentence first before the other sentence. I would have started there, and then now that we know that, now we can say the system of equations has one solution, okay? Solutions are how many points the lines intersect at. So once we saw they have different slopes, they're going to be angling different, they're going to intersect at one point. Look at example 2. Harrison and Pia each buy X comic books. Harrison also buys an action figure for $15 while Pia buys a different action figure for $12. Could they each spend the same amount, Y, and buy the same number of comic books? And explain. Okay, So they're each buying the same number of comic books. Harrison bought an action figure for $15, and Pia bought an action figure for $12. So think about their equations here. This first equation would be for Harrison. He spent 5x plus 15. 5x is for the comic books plus $15 on the other action figure. Pia spent 5x plus 12. 5x for her comic books and $12 for the other action figure. And you might wonder about the 5, where they're getting the 5x. If you look over at their picture where they like to give information a lot of times, that's where they're telling us the comic books are $5 each. So $5 times X comic books is 5X. So if you look at these equations, first of all, we're going to look at the slope. So the slope of both of these lines is the same. So these lines are going to be angling the same. If the lines are angling the same, either they're going to be parallel and they're never going to intersect, or they're going to be the same exact line. Well, looking at the y-intercepts are different, which tells me they're not the same exact line. They're angling the same direction though, so that means these are going to be parallel lines. Okay, so we have the slopes were the same, y-intercepts were different. Those two things combined tell me that the lines are parallel. I know right then the lines are parallel to each other, which means they don't intersect. And if they don't intersect, that means we have no solution. Okay, there's no way that they could spend the same amount of money and buy the same number of comic books, because they bought these other action figures that were different amounts. Harrison's always going to be spending a total of $3 more than Pia, right? $15 action figure versus a $12 action figure. Okay? So there's no solution for that. And we can tell that even without making graphs, even without graphing these out, we can tell there's going to be no solution. Example 3, Corey and Winnie each bought X pounds of cheddar cheese and Y pounds of tomatoes. Corey spent $12 at the supermarket. Winnie spent $24 at the farmer's market. Could they have bought the same amount of cheddar cheese and tomatoes? Okay, so looking at the information here, Corey, first of all, for X is the cheddar cheese. So Corey went to the supermarket. So it's $6 a pound times X pounds. Okay, this is where Corey went. So cheddar cheese is X, so that's where they got the 6X from. $6 times X pounds. Tomatoes is Y, and that's $2 a pound. So $2 a pound times Y, that's where they got the 2Y. And Corey spent $12 altogether. So 6X plus 2Y equals 12 for Corey. And then for Winnie went to the farmer's market. So for the farmer's market, we have different prices. So the cheese is more expensive this time. That's X. So $12 a pound times X pounds, that's 12X for the cheddar cheese. And then tomatoes $4 a pound. We bought Y pounds, so that'd be 4Y. And Winnie spent $24 altogether. So both things were more expensive at the farmer's market, but that's kind of a trade-off. Some people like that, and they get more fresh produce that way. All right, so these are the equations we're looking at. They're asking us to write each equation in slope-intercept form. Slope-intercept form, again, is y equals mx plus b. So we're going to solve the equations for y. So in order to solve for y, we could subtract 6x on both sides here first. And then the last step, we've got 2y. We want y, so we would have to divide everything by 2. They're multiplying by 2, we divide by 2. So when we do that, we get y equals negative 3x plus 6. Okay, so that's the first equation. That's Corey's equation. And then for Winnie, we're going to do the same thing. So we're going to try to get y by itself. So if we subtract 12x first, and then we divide everything by 4, we get y equals negative 3x plus 6. That sounds familiar. That was the equation we had for Corey. So if you look at that, both those equations are the same. If they're the same line, every pair on the line is a solution. So with the information they gave us, they had to have bought the same amount of cheese and tomatoes. Okay, and here's the idea on the side, this box. If one equation is a multiple of the other, the equations represent the same line, and it has infinitely many solutions. So another way we could have done this, instead of going through the whole process of what the book did, another way is if you can multiply the equations by something and they come out the same, or divide one of them, then those are going to be equivalent equations. So in other words, we take Corey's equation, if we multiply that by 2, that would give us 12x plus 4y equals 24. Okay? So that gives us an equivalent equation. That means that those are going to be the same equations, and we're going to have infinitely many solutions. Basically what it boils down to on this problem, if you look at all the numbers, it just happened that everything was twice as expensive at the farmer's market than the supermarket. And also, Winnie at the farmer's market spent twice as much as Corey did at the supermarket. Okay, so since it worked out just exactly like that, that's how we know that works, and that they bought the same amount of cheese and tomatoes. So if we look at the try it, they're asking how many solutions does each system of equations have and explain. So on this one, they already have the equations set up for us. It's just a matter of us looking at this and figuring out how many solutions we have. So first thing we want to do is look at the slopes of these lines. So remember, y equals mx plus b. M is our slope. So negative 3 is the slope of the first line. Negative 3 is the slope of the second line. If those were different, if we had different slopes, that means the lines would be angling differently and we would have one solution. Since they're the same, we're either going to have parallel lines or we're going to have the same line. We're going to determine that by looking at the y-intercept. So y-intercept of the first equation is 5, y-intercept of the second equation is -5. So same slopes, but different y-intercepts, just to kind of sketch out a little bit what this would look like. One has a y-intercept of 5, slope of -3. One has a y-intercept of -5, slope of -3. This is kind of what's happening here. Okay, so the slopes are the same, but the y-intercepts are different. Means these lines are parallel. And if the lines are parallel, then that means we have no solution. There's, in other words, nowhere that these lines are going to intersect because they're parallel. Parallel lines never intersect each other. We go over to part B. Kind of the same thing. We're going to try to compare our slopes and then compare our y-intercepts, depending if the slopes are the same or not. We got a little bit of a issue here, is that second equation doesn't look too nice. So let's try to get that looking a little nicer to start with. The goal would be to get it to be y equals something. So one thing we can do, first of all, we can add 15x on both sides of the equation. It's up to you. I'm going to go ahead and do it here. This is a little bit of doing multiple things on the same step, but you can also add 20 on both sides on the same step. Okay, we want to clear everything out except our y term. Get that y term by itself, and then we can solve. Instead of 5y, we're obviously wanting to just know y equals something. So to get it to be a y equals instead of 5y equals, they're multiplying by 5, we need to divide everything by 5. When we divide everything by 5, we're going to get y equals 3x plus 4. And now that's going to be, oh, look at that. Our other equation was y equals 3x plus 4. That was a pretty good disguise. That's what I kind of talk about when we got equations like this, where it's nothing, you know, it's really nothing like what we're used to seeing of just a y equals equation. And then you work it out, and it ends up being the same equation as the other one. It was the same equation, but in disguise there, basically. So since these equations are identical to each other, we are going to have infinitely many solutions. Again, we're looking at our solutions are where the lines are intersecting each other. The lines, if they're the same lines, the lines will always intersect each other. They intersect each other at any point. If you give me one point on one line, the other line's going to be right there also, because these lines are exactly the same as each other. This gives you a little bit of an idea of estimating solutions by inspection, and we will continue this in another video. Have a good day.